Okay, then what are the different priority policies and how is it taken? So there are many ways the server serves the customer. There is a way that is preemptive and non-preemptive. What preemptive means? Preemptive means it takes into account the priority of the customers in the line the server is serving. So if a server is serving a customer with a lower priority and a customer with a higher priority appears, then the server stops serving the customer with a lower priority and starts serving the customer with the higher priority first. So that is a preemptive strategy. And a non-preemptive case, the customer is served first by the server. So the server only completes serving the customer it is already serving, and then it moves on to the next customer. And based on the job size, this is anticipative or non-anticipative. It depends if the customers are being served have a higher job to serve or lower job size to serve. So in non-anticipative case, the job size is not taken into account. So whatever the customers are being served by the server are served without any idea of the job size. But when a customer with a lower job size arrives, then the customer with a higher job size experiences a penalty by the server in the idea of more waiting, while the server starts serving the customer with the shortest job size. That is the case of shortest job first. So that is anticipative. So we have different policies: preemptive, non-preemptive, anticipative and non-anticipative in the head of line strategies, where in the head of line there is a waiting line, and in the beginning of the head of the waiting line there is the customer which must be served first by the server. Now this preemptive, non-anticipative and non-preemptive strategy is the FCFS strategy, which is the first come first serve, FCFS. That is non-preemptive and non-anticipative. That means it doesn't matter whatever is the job size, whatever is the priority, the customer is always served completely and then the server moves on to the other customer. And also for the static priority case. And then there is anticipative but non-preemptive. That means the priority is not taken into account. In that case, that is our SJF, where the shortest job customer is served first. So shortest job first, SJF, is non-preemptive and anticipative. And then we move on to the preemptive case, where the first priority is taken into account. So a higher priority customer is served first while interrupting the previous customer, and that is the least attempt service, LAS, last policy, where it is preemptive and non-anticipative. And then there is the last one where it is both preemptive and anticipative. That means SRPT is the name, shortest remaining processing time, where shortest job and higher priority is given the first service. So SRPT is the shortest remaining processing time, is a preemptive anticipative case. Now we will go through the whole conservation law. Now what is the conservation law? So the conservation law is given by for J classes of customers being served by a server. So every customer experiences a mean waiting time E of Wj, and every customer has a coefficient rho j, and the system utilization coefficient is rho. So for J classes of customers which are prioritized in the basis of 1, 2 up to P levels, with the lower level numbering having the highest priority, for the J classes of customers, they have their own utilization coefficients of rho 1, rho 2 up to rho P. That is in generic class terms rho J, and the total system utilization coefficient is a summation of all the rows, that is rho. Rho is equal to rho 1 plus rho 2 up to rho P. So this ratio rho j by rho for and multiplied with the mean waiting time for the class J, this for obviously true for one class J. Now, of course, we have to sum up in all across entire class, all the P cases. So, is the summation J is equal to 1 to P. This is the total waiting time should be equal to W naught divided by 1 minus rho, which we have already achieved for the MG1 MG1Q. The mean waiting time should be equal to W naught by 1 minus rho, and this relationship must be true, and that is the conservation law for Hall policies. And this actually is equal to the waiting time experienced for FCFS policy. So that is the conservation law. And then if we go through specific classes, what is E of Wj? Now, how do we understand E of Wj? The expected mean waiting time for the class J. So the E of Wj is given by W naught divided by 1 minus rho I summed up from I is equal to 1 up to j minus 1 multiplied with 1 minus sum of rho I is equal to 1 up to j. I is equal to 1 up to j, where j is the class. Okay. So high variance service times of low priority customers. So the customers which have low priority and service times are highly variant, they will also affect the high priority customers in case of non-preemptive priority. Now, why do we need, what is the purpose